Hello friends, well this presentation is about a new structural system called the cables. Now cables are some kind of a wire-like system which can basically resist axial tension. Besides axial tension, it cannot resist any other force and is fully flexible to all kinds of forces apart from axial tension. So it's flexible to compression, it's flexible to bending, it's flexible to torsion. So if we are to design some sort of a cable system, we are going to design it in such a way that the loads falling on this cable system should be essentially and strictly axial, and it should be some kind of an axial tension, right? So let us see whether we can build a beam bridge, right? And if you can modify the beam bridge to some sort of a cable and suspension bridge, what are the advantages? And the exercise that from a beam bridge to how to a cable suspension bridge, this exercise will basically make us clear about the whole concept of cable and suspension bridge. Let us proceed. For example, in a beam bridge, it was some kind of a thing like this, wherein, let's say this was my deck, and there were some beams, right? There were some beams which were attached, let's say like this, and this will be essentially a hidden line, right? And the whole load of the deck, where vehicles are flying, suppose on this deck, and the whole load of the deck falls on the beam, and the beam takes in this load by bending essentially. But the problem here is that the beam have their own weight, and essentially this thing is contributing to the dead load, right? So essentially we cannot make the spans longer because this beam has its own weight and it is contributing to the dead load, and as such we cannot make a bigger spans. Here in cable and suspension bridge comes to a scale. What we do, what the general principle in cable and suspension bridge is that there will be this deck and vehicles will ply on it, right? If we can suspend this deck by some kind of an arrangement like this, right? And then if we can build some kind of an arrangement like this, wherein this is firmly rooted, this is a kind of a firmly rooted structure, and this are my tensional members or the actual tensional members of the cables, and the weight of the deck is in the downward direction, and it will essentially create some sort of a tensional force in this wax. So the wax will be essentially under tension. As the wax will be under tension, as is pretty evident, there will be a compressive force along this, I should say, along this piling, right? So the whole concept of the cable and suspension bridge is this, and these cables are basically made of strands of high structural steel, so their strength is a lot. So essentially it can take in the same force with a lesser cross-sectional area, as the stress it can carry is many times bigger than, is say 5 or 6 times bigger than that of ordinary structural steel. So essentially it is not contributing to the weight as such, and as such we can build some sort of a longer span with a lower weight structure. So the cable and suspension bridge are essentially long span, lightweight structures. So how does the load distribution and how does this cable suspension bridge originally looks like? So a cable suspension bridge looks like some kind of a thing like this, wherein let's say that this is my river, right? And I have to build a bridge, right, so that commuters can go from this to here, from here to here. So this is essentially, let's say, my river. Now what can I do is, let us build some towers. These are my 2 towers and I route this to the ground, right? Then what I do is that I build some kind of a cable system like this thing, right? And this is again routed here, and this is again routed, let's say here. And then attached to the cable system, this is my cable system, this is my, say, let's say my pylon, this is my anchorage, right? And this cable system has some kind of a suspender attached to it, right? What are suspenders? Suspenders are nothing but some sort of vertical cables like this. Right. These are my suspenders, say. And from the suspenders, the deck hangs. So vehicles, commuters can fly over this deck, and the deck creates some sort of has some sort of a gravity load in this direction. So this will essentially create some sort of a tensional force in this suspenders. Right. The suspenders will transfer this load to the cables, and the cables will be under also some sort of a tensional force. Right. And then it will be transferred to this anchorage block, which will be again under some sort of a tensional force. So the whole load path looks like this, that the deck exerts some sort of a vertical load. The suspenders has some sort of a tensional load developed in them. The cables also have some sort of tensional load, and this tensional load is carried to this pylon in the form of compression, because we know that if there's a cable like this, and if this is my pylon, if I pull it like this, obviously there will be a compressive force along the pylon, right? So this is some sort of a compressive force, and this is transferred to the ground, and then the anchorage takes in some kind of a tensional force due to this tension that this cable applies here. So this is the basic concept of a cable and suspension bridge, basically. Now one has to note one thing